Question 9, I've drawn the triangle to start with, and we must draw our forces on here. We know that the rod here is uniform, so that's mg acting at a distance a from the end, and also there's 3 mg. Let's put it over here somewhere, 3 mg. And we know that that's acting at a distance x from the end. So we'll put sort of x up here if you like. The diagram can get a bit complicated at this point, but it's important to have a good diagram. T, the tension in the string, is acting that way at what we're told is an angle alpha, where tan alpha is 3/4, meaning again that sine alpha is 3/5 and cos alpha is 4/5. So we need those values later. Well, here at A, there is some kind of reaction force we don't really know that much about, and it will be sort of split like that, but we don't really know much about it. So the way to approach the first part of the question is to take moments at A. So if we take moments at A, we don't have to worry about what's going on there, because moments at A will immediately remove any forces at A. So moments at A, we've got, if I look clockwise, that's mga plus 3 mgx, and that's going to be balanced by the anti-clockwise moment of t sine alpha times 2a. And so then if we tidy up the left-hand side, I've got mga plus 3x is equal to 6ta over 5. Sine alpha, of course, was 3/5. And so finally, therefore, t is 5 mg a plus 3x, all divided by 6a. That's what we were asked to show. For part B, I'm going to resolve horizontally. We're now told for part B that the magnitude of the horizontal component is 2 mg. So going back to our diagram here, I know that there's a 2 mg horizontal force. Of course, the whole thing is in equilibrium, so the 2 mg force is exactly balanced by the horizontal component of the tension, which means that if I resolve to the right using F equals ma, then I get 2 mg minus t cos alpha must be 0. And I know an expression for t because I worked it out in the previous part. So therefore 2 mg is equal to 5 mg over 6a, a plus 3x, that's t, and cos alpha, of course, is 4/5. And so if we work through that, the mg's, of course, will cancel, and so we end up with 2 equal to 2a plus 3x over 3a, and so therefore a plus 3x is equal to 3a, and therefore x is 2a over 3. So that has worked out x in terms of a. Then it asks us to find the value of tan beta. Well, the thing to do here at this stage, let's look back at our diagram again up here, is to indicate that there is some kind of vertical force. And in my working, I just called it N. But you can call it whatever you like. But let's go with the vertical force at there. So knowing that, we can do part C then. So if, in fact, I just redraw that particular bit of the diagram, I've got a force of N going vertically. We know that it's 2 mg horizontally, and of course there's mg and 3 mg coming down. So if we resolve vertically using F equals ma, then N plus T sine alpha, so let's just pop that in, there's T, and we know of course that this is alpha, so that's T sine alpha going vertically, and that's minus 4 mg, and that's going to equal 0 because it's in equilibrium. Let's get rid of that. And so therefore N is equal to 4 mg minus T sine alpha, which is 5 mg over 6a. That's a G. And that was 3x plus a, wasn't it, for t, multiplied by 3/5 because that's sine alpha. And if we work this out, and we already know, don't we, from before, that x is equal to 2/3 of a, so we know that x is 2/3 of a, then n, as we work through this, becomes 4 mg minus 3 mg over 2, and then n becomes 5 mg over 2. So n is 5 mg over 2, and so we've got horizontally, let's go back to it, we've got 2 mg that way, 5 mg over 2 that way. So if beta is the angle just tucked in there, it's a bit of a small diagram, let's just redraw it here. There's 2 mg there, 5 mg over 2 here. So therefore, if that angle is beta, then what we can say is tan beta is 5 mg over 2 divided by 2 mg. So therefore, tan beta is 5 over 4. And finally, D. Okay, since T, the tension in the string is 5 mg over 6a into 3x plus a, then we require 3x plus a over 6a to be less than or equal to 1, because the maximum tension is 5 mg, so anything over that and the string breaks. So if that's less than or equal to 1, then 3x plus a must be less than or equal to 6a. So 3x must be less than or equal to 5a. Therefore, x is less than or equal to 5a over 3, which puts how we would restrict the possible position of P.